Greetings and welcome to our 8th test and measurement video. We're looking at some of the best oscilloscopes available right now. Today's instrument is a Keysight Technologies, formerly Agilent, MSO-X 4054A oscilloscope. This 500 MHz 5G-SAS instrument is well suited for simultaneously displaying an analog signal in the time domain and its Fourier transform version in the frequency domain. For this experiment, we obtain and take apart a plug that is compatible with the headphone jack in a Yamaha electronic keyboard. Since it is a stereo plug, it has 3 terminals, and what we want to do is hook onto one channel and the common plug. My first impulse was to solder wire leads to the audio plug terminals, but I decided it would be easier to just connect the oscilloscope probe directly to the plug. The polarity doesn't matter if you have an ungrounded electronic keyboard like this one. This can be ascertained by looking at the power cord, which has an inline transformer. It is a true isolation transformer, which can be verified by means of a multimeter such as this Fluke 287. Grounding is not carried through to the output of an ordinary transformer, or if the primary is shorted out to the secondary, power line grounding may go to the secondary, in which case, if the probe ground lead is connected to the side that floats with respect to ground potential, spark and smokes may be expected. Notice that if a plug is inserted into the headphone jack, as with most audio equipment, the feed to the speakers is killed. So when doing this video of the oscilloscope display, we'll have to capture the sound separately and dub it in. The Yamaha electronic keyboard is capable of synthesizing sounds resembling a great many musical instruments, which may be selected by turning a knob. Not included, however, is the sound of a tuning fork, which makes a simple sine wave with no harmonics. To illustrate, here is a sine wave picked up off the internet. Now let's take a look at some sounds synthesized by the Yamaha keyboard. Here is a baritone saxophone. Notice that the waveform is strikingly different from the sine wave as made by a tuning fork. And here is the sax waveform with its frequency domain graph superimposed. Notice that the signal power is spread out in contrast to the sine wave, where it occurs in a narrow band. Next, as produced by the Yamaha keyboard, here is what a flute sound looks like. This is the analog waveform for the flute sound. As you might expect, the waveform, compared to that of the saxophone, is far less spiky, resembling a little more the sine wave. To verify that impression, take a look at the superimposed fast Fourier transform view. In the frequency domain, you can see that more power measured in decibels is concentrated at the fundamental frequency, in contrast to the saxophone waveform. I hope you enjoyed this demonstration, which used the Keysight MSO-X 4054A. See you next time.